everyone. Welcome to this Monday's Sesame Colloquium. Very honored and delighted to have with us Professor Ricardo Nemirovsky from San Diego State University. He'll be speaking to us about animating mathematical symbols. I wrote a few words, but I guess I might have got a bit carried away. It was immediately after coffee. Font 9. Just bear with me, right? So, the French philosopher and Nobel laureate Henri Bergson called for a radical rethink of how we perceive motion in the sciences. In his 1911 Oxford lecture on the perception of change, Bergson stated that movement is reality itself. Bergson acknowledged that scientists must freeze motion on paper, make it immobile, in order to examine the transforming world. Just think of classical images in physics or chemistry textbooks. Quote, "Nothing is more legitimate in practice," Bergson said. But then he adds, "But when we transport this habit of mind into the domain of speculation, we fail to recognize the true reality. We deliberately create insoluble problems. We close our eyes to what is most living in the real." Bergson's critique of the technoscientification of our experiences of time, motion, and change have inspired many leading reform-oriented educational researchers to examine relations between, on the one hand, children's naturalistically animated classroom and extramural activities, whether concrete or imaginative, and, on the other hand, the static visual displays, such as graphs and symbolic notations, that children are to accept as the formal, immobile, and parsed representations of their informal, mobile, and flowing experiences. Much of the work of Jean Bamberger, Andy DeSessa, and Jim Caput have been precisely on this tension between the songs of experience and how, in mainstream instruction, these songs are pinned down like butterflies, never to move again. And Ricardo Nemirovsky has taken this visionary pedagogical and analytical work to a new realm. Professor Ricardo Nemirovsky of San Diego State University is a true Renaissance scholar who is equally fluent in mathematics, philosophy, art history, and technology, and combines these fields in rigorous research of education that is at once historical in its depth and futuristic in its reach. Ricardo's list of publications spells out the emergence of a new paradigm in the cognitive and learning sciences. Over 20 years ago, and still at Turk, Ricardo argued for a new conceptualization of what it means to know and practice mathematics, and his conceptualization positioned embodied, situated, sensory-motor activity as the cognitive substance and vehicle of mathematical learning and performance. To understand the new mathematical concept is to come to inhabit new territories. Ricardo's trenchant and assertive manifestos on the embodiment of mathematical knowing, such as in the Proceedings of the International Group for the Psychology of Mathematics Education, list all the mantras you need to make sense of the new paradigm and join in. It is not the case that conceptual knowledge is expressed through action. Rather, situated sensory-motor activity is the primordial knowledge. It is the aboutness of what we call concepts. Thinking is motion, and conceptual know-how is intrinsically mobile. In his scholarship, Ricardo is always ahead of the curve because he is inventing the curve as he goes along. If you want to know what's the next big thing in STEM education, design, and research, just look at a recent Nemirovsky article. Or better, look at an article from 10 years ago. It is through his work that innovative paradigms waltz along the familiar sequence of the esoteric, that is soon considered innovative, then groundbreaking, then the new buzzword, and then just the commonplace thing that everyone's doing. By the time his views have been accepted as mainstream, Ricardo is already far ahead, breaking yet new grounds. Personally, I've been fortunate to receive Ricardo's occasional voluntary mentorship for about a dozen years now, and I've enjoyed the hospitality of his research center, Crimsey, in San Diego. My lab spent this morning with Ricardo, looking at video clips from our own research on mathematical articulations of motion. And so I'm thrilled to have Professor Ricardo Nemirovsky join us today to give the Sesame Colloquium. Please join me in welcoming Ricardo to the Grad School of Education.
So I'm happy to be here, and I'm really sharing with you work in progress or ideas that we are trying to develop. And so to start, let me show you. So this is a video of a 5th grade class in Massachusetts. we don't hear sound because it's silent. She is working on similar triangles. So that the ratios are the same. All right, so what I wanted to show here is that on the one hand, there is here a human being, a young student, who is reasoning about similar triangles and equal ratios, but it is traditionally common the assumption that what the thinking goes on behind, this is like a stage, but behind the stage there is the thinking. And so the task of teachers and researchers is to figure out what's going on here. So you look at someone working, in this case, with the overhead projector, and you see the girl gesturing, talking with different facial expressions, posture, gaze, looking at different things. And the task of the educator and the researcher is to figure out the reasoning, the strategy, the schema, the conception, the theory that she is expressing. And part of the difficulty is how you do that, because there is no one-to-one correspondence, and there is a lot of interpretation in how you get to this realm, to this mental realm. So it's a mental model of what she's doing here. And so there is a whole tradition about this split between this side and that side. And so traditionally there is like jumping from one to the other. There was a whole era of behaviorism in which what matters is what is the visible responses to certain stimulus, and there are eras of mentalism in which you are interested, people are interested in figuring out the machinery behind the body. And so there was, in the first half of the 20th century, behaviorism was in the US very prominent, also in other countries. And after the Second World War, mentalism became much more prominent. And now there are a number of people who are questioning this split in different ways. And so within mentalism, there are all kinds of differences. For example, there is the mentalism that sees what happens in the mind as internalizing culture, so it was more the Vygotskian type, or individual development, that individuals, through experimenting with things and with others, develop certain mental schema, more Piagetian. And so both mentalism and behaviorism are very diverse, and there are all kinds, and people position differently along this realm. But from the perspective of some of us, these differences still remain centered on mentalism. And so part of the questioning is how we can develop a view of learning and investigating learning and teaching that is not dualist, that it doesn't split the human being into mind-body and either prioritizing one or the other. And there is a growing, in the last 20 years, a growing phrase of embodied, growing in the sense of more widespread, of the term embodied cognition. And I say here, I think is using the term embodied cognition signals a certain intention to overcome the mind-body split. But it cannot be enough, the label, because it's the same as it's saying, instead of body and mind, now we talk about body-mind, or mind-body. Quick, so that there is no pause in between. And so there, although I think there is something healthy about this call for embodied cognition, there is still something that has to go beyond the label and rethinking some basic ideas that otherwise the split between mind and body reappears. It like sneaks in from the back door. Like I think some people think of embodied cognition in terms of grounded metaphor, so that there is the body and then the abstract ideas are metaphors of body motion. And so that is a version of embodied cognition that still has, there is a metaphor, there's the mind side, and there is the concrete and the bodily thing. And maybe there is some sort of communication, but still there is a mind-body split. And so ideas, I think it's very important that, and I think many people are trying to do this, just how to give substance to this idea of embodied cognition, that is not just a phrase. How to rethink the basic notions of learning and thinking and teaching in a way that body and mind are don't need to be bridged, but don't show up separately. Because the issue is not to bridge these two different things. Why in our culture these two things split up to start with? And so I'm working on these two aspects, one on affects and one on animism. And the talk that I thought for today is on the second one. Affects, well, there is a book in progress, but animism is an area more recent. And I just want to say that there are other people who also are attempting to rethink everything in ways that don't take for as a starting point this mind-body split. And there is people working on, for example, Karen Barad, she works on agential realism. So the idea that matter is not inert and that there is agency in matter. Or there is quite a few researchers in actor network theory that try to elaborate the idea that objects have agency and what that means. And sometimes this gets, there is a label post-humanistic, because it's, in all these attempts to attribute agency to other than human, there is something that is the uniqueness of humans seems to be widespread in things, in matter, in the world, and so there is something of post-humanistic in these traditions. But this is just to give just to say that there are many attempts and there are many people working on these issues. But I will focus on this animism. So animism is, as well, this is the case of Jean Piaget, but this is a generic traditional distinction, is the attribution of agency to whatever is lifeless. And so attributing agency to the clouds or to the river is a traditional understanding of what animism is. There are also, I find always Darwin is an amazing person. And there is this statement that Darwin said that higher mammals may be animist as as people. And we are all fundamentally similar, he wrote, and all may see inanimate objects as inhabited by agents, as when his dog, this is something that he observed, seeing a parasol moved by the wind, barked and growled fiercely. And so the idea that animism is not just human, that all living beings are animist. Now, this is a quotation that says that against this traditional idea that the first modern use of the term animist comes from Taylor, a British anthropologist from 1860 something. And so is a quote that says how for the last 20 years, I would say, there are new ideas of what how to think of animism, particularly from anthropology. And so it's central to the approaches of what is often called the new animism. It's a rejection of previous scholarly attempts to identify it as either as metaphoric, like a projection of human society onto nature, or as some sort of imaginary delusion, exposing primitive man's inability to distinguish dreams from reality. So there is a whole very diverse set of efforts to think animism in different ways that are not based in those traditions, in scholar traditions. And the one that I will focus on is by Tim Ingold, and this is his well, there is a lot that he wrote, but this is the little, in a nutshell, thing about what he thinks of animism. And so he says animism is not about restoring agency to objects. It is about bringing things back to life. It gives us room to breathe. And so there is a certain critical view of modernism, or the Western view of things, that sees like this split between inert matter. And it used to be that people thought that animals don't have feeling, for example, so they were machines. And so this split between everything around us that is basically dead and we that are alive. And so there is something about bringing things back to life, that's seeing life in the world around us. And also there is something about getting room to breathe. And there is something about that is very difficult to breathe if all the world around us is dead. And so about the first part, what I interpret, animism is about bringing things back to life. So what I will interpret this as that this involves endowing things and symbolic expressions with felt qualities, like the process of, for example, saying this room is overwhelming, or this painting is intriguing, and all these attributions of felt qualities, because intriguiness is something that we feel, and overwhelmed is something that we feel, and so seeing felt qualities around us is what I take to be as bringing things back to life. It says animism gives us room to breathe, and so I will pursue the relationship between lifeless mathematical symbols and not having room to breathe. So I will illustrate these ideas with two episodes. One is with a mathematician, a topologist, and he's talking about a paper of his, and another is with an undergraduate student math major undergraduate student. So first about the topologies, he's talking about a paper that he wrote that is related to quantum mechanics. So it is topology, but it has to do with quantum mechanic processes, as we will see. So he's sort of explaining micro about these ideas and how the paper works. So first I will show you, let me see the sound. They put it like here?
Yes.
If you had a classical spinning particle like a ball, I mean, its angular momentum is described by a vector, which...
Let me start.
Classical. If you had a classical spinning particle, classical. If you had a classical spinning particle like a ball, I mean, its angular momentum is described by a vector, which has the axis about which it spins, and the magnitude of this vector is the amount of the spin. So your sort of your space of possible spins would again really be R3. It's just all possible vectors you could draw pointing out here.
So he is describing the case of the idea of angular momentum in classic mechanics, and he draws this ball that turns. So I will go through. This is the beginning.
Classical. If you had a classical spinning particle like a ball.
So first, he's drawing a ball that is a 3D object, and he's using this convention of a dotted line there. That is a part that you don't see. So these are conventions, but he's creating on a flat surface something that has volume. And
its angular momentum is described by a vector.
So he says the angular momentum, he adds this arrow, but also he gestures up. So there is the angular momentum is described by a vector, and he adds an arrow there that he chooses to put on the North Pole, so to speak.
Which has, the axis.
So if you have the angular momentum like this, and so it says is the axis, and he draws the arrow but puts the ball into movement, right? This is turning, it's making the ball turn, so that the arrow would be the angular momentum that corresponds to that turn. So that's another piece that he adds here. So is above which, and he draws a curvy arrow that it relates to the vertical vector. So this is the motion going around the vector.
And the magnitude of this vector is the amount of the spin.
So spins and the magnitude of his vector, when he says the magnitude, he points something that might be like the length of this arrow, and then he says it's the amount of spin, and he puts the ball into spinning it. And
so you're sort of...
These are transitional moments that there is in terms of animating this ball, he's animating certain aspects, and he's getting ready to animate a new aspect.
Your space of possible spins would again really be R3. It's just all possible vectors you could draw pointing out here.
So what is the angular momentum is vertical going upwards if the ball is turning like this. But in general, it could turn like this, or so he says the space of this vector is 3D space. It's R3, real space, 3 dimensions. And so he does like draw pointing. He says pointing out of here, and he draws a few of these directions. But it's also is the bringing into presence all the possibilities that he just with two says all of these. So now he will talk about the quantum case, but in any case, just from what we saw in the classic case, this is what I'm trying to characterize as animating, that is not only to bring into motion something that is a symbol or something that doesn't exist at all, but putting it into motion, but also making it attributions of, it could go anywhere. There is that feeling, if you think of 3D space, well, I could go, I do something like that, and it's the feeling that it has this freedom to go in any direction. and so there is, this is a little example of what I mean by animating a mathematical symbol. Now he starts to talk about the quantum case, and he says the quantum particle.
The quantum particle, the quantum angular momentum, belongs to this space, let's call it little j or something, and it belongs to a space of values like 0.
So usually the letter J is used for angular momentum in quantum mechanics. And so he is naming the little j and then preparing to write discrete values, like the quantum angular momentum can only have certain discrete values.
I can't remember what units is measured in, but probably it's a Planck's constant or something like this. So there's some sort of minimal possible angular momentum, and there are integer multiples of that.
So there is multiples. He's writing integers, but he says there is a Planck constant. That this is 1/2, 1, 3/2, 2, and so forth. So he is the symbol, the symbology that he is developing talks about the sequence of discrete values. But let's see how he animates it.
So there's a sort of countable discrete space of possible spins. So electrons have a spin and a half, but the sort of magnitude of the spin, so to speak, is really fixed.
So there is, in this quantum discrete case, there is a discrete, and he doesn't do this anymore. It's this ball now that is really fixed. So there is this constant discreteness of here and here and here. It's not the smooth continuous. So this is a form of, this is one way of animating these symbols here. And so you see that the animation it involves him and the symbols, because he's writing. When you write these, you also write different numbers here that are different from the previous one and the following one. But this also invites him to explain it by saying it's fixed like that. So this is a little bit.
The thing is, that is what we're trying to do. We really don't care about what happens in the middle. We think about a black box with lots of guys going in. Measure the composition. We're simple beings. We've learned how to combine 2 guys together. So we just combine 3 guys.
Okay. So We have a dark. Dark. So he's talking about the problem of adding angular momentum. So you have 3 electrons, and how do you get to the result of these 3 angular momentums? So he said say that you have J1, J2, and J3, and so we know how to add 2, but then how do you add 3? So he says first you can add here J1 and J2, then you obtain something that he called J4, I believe, and then you add these and you obtain J5. I think he later changed the numbers. But what he's telling Michael is that the way in which angular momentum is added is by 2s. And so Michael Michael asked him, why is it that you don't do like if you have J1, J2, and J3, that you have the 3 of them coming together? Why you have to do 2 and then 2? And so that's what we will see his question.
Just a completely different question. In this system, is it the case that you never encounter something like J1, J2, and here you have J3 coming in?
Well,
so that's the question. So
you never have the 3 coming in. The thing is, that is what we're trying to do. We really don't care about what happens in the middle. We think about the black box. We've got some guys going in and measure the composite sequences you're relevant. Right.
So the first thing that he does is to say, well, yeah, we want to do that, add 3. But he said, but let's think of this is, you have here a black box, and he erased this meeting of the 3 particles and puts a black box. Oh, thank you.
But since we're sort of simple beings, we've learned how to combine 2 guys to get 1. So we just say, okay, if I want to combine 3 guys, let me just do it in 2 stages rather than being over ambitious and try and write this sort of single, once and for all formula.
So his justification, he said, we are simple beings, and so we know how to add 2. So he says, instead of being over ambitious, let me add 2, and then I add the 3rd one. And
But there is one other observation very close to what you said there, which is, why don't I use the second 2 guys first, and then have the first one come on? And if I do that, it'll be the same kind of thing. I'll get the same answer at the end, and it'll be the same collection of these irreducibles that sort of flies out of the other end as a big direct sum. But they'll have been formed in a slightly different way. There would have been some different possible family of labels, J5, coming in the middle here. So, and then again, it will be no, that's not the one J5, that's the one J6.
so there is first this sort of natural impulse to put a black box there. Is like, let's not look at these 3 all together at once. Which in principle it makes sense to think it that way, because these are 3 events. Like, for example, if 3 people are going to meet in a coffee shop, then it does make a difference if 2 come first and the 3rd one come later, or the 3 meet at the same time, and they would all say, oh wow, we were really coordinated. And so there is this explanation that we are simple beings, and that is being a simple being is a felt quality. And so he says that by using the scheme of 2 and then a 3rd one, it's simpler. It's not that we as mathematicians are simple beings. The symbols also are simpler. And so that's what I mean by endowing things as symbolic expression with felt qualities, by simplicity. Now, what he says is, however, there is a possibility that I have J1, J2, J3, but instead of adding first J1 and J2, I will add the second one first. And then I obtain, he says this is J6, and then I add J1 and obtain J5. So you obtain the same result, because in the end you have 3 electrons or 3 particles that come all together, but these are 2 different ways of obtaining that same result. And in one case there is an intermediate J6, and here there is an intermediate J4.
And if you build up a language of what these graphs are actually supposed to mean, it would amount to doing something like J1 here, J2, J3, and J5. And on one side I have this kind of graph with the J4 in the middle. And on the other side I have the one where the 2 and 3 connect, the 1 and 5 connect.
So let me,
It's helpful to have that.
So he draws a line here. He will put these 2 diagrams together. And so there is a J1, J2, J3, and J6. And so on the one side, there is the first one in which we add J1 and J2 first, so we add these 2. And then the result, which is J5, joined with J3 and ends it in J6. So it's doing the first diagram but sideways. And the second diagram, it is J2 and J3 are added first. And then the result is J6. This is supposed to be 5. So the result is J6 that added to J1 goes to J5. So it's the same diagram but put sideways on the right side. So it's turning these 2 that are like this into sideways.
And if you build up a language of what these graphs are actually supposed to mean, it would amount to doing something like J1 here, J2, J3, and J5. And on one side I have this kind of graph with the J4 in the middle. And on the other side I have the one where the 2 and 3 connect, the 1 and 5 connect. And they're grouped like 6. Something like that. Let me erase this sort of construction line. That's where it starts to look like a tetrahedral sort of arrangement of things.
So his paper is called Tetrahedrons. This way of adding angular momentum, it uses what in physics textbook is called the 6J symbol. And so his paper in the title has a 6J as well as a tetrahedron. And so I made here with strings this diagram without this line. So I have a string all around, and then there is a string here and a string there. So if you pull it up, this is flat, but if now you pull it up, and imagine that the sides are straight, you have a tetrahedron. So, and tetrahedron, in topology, it doesn't matter if lines are straight or curved. So, actually, when he erased that line, Mike could say, because he saw the tetrahedron, and so he saw this figure because topologically there is no difference; they are equivalent. And it turns out that the tetrahedron has certain symmetries that then in his paper he analyzed how these symmetries get expressed in quantum mechanics with angular momentum. But this is another element of animating this mathematical symbol without necessarily, well, he draws a tetrahedron. And then that is bringing into visibility something that at that so far had been very obscure for us. Where does this tetrahedron come from? Now, you see that there are symbols on this side of the blackboard. And he uses, what happened is that the angular momentum of a particle is not just a vector, like in classic mechanics, but it's a space of vectors. And there is a set of vectors that can have different orientations and values. Yes?
I'm just asking this now because I know you're going to go on to the second case, but I can wait till later if you prefer.
No, go ahead.
So there was part of his the video that I temporarily I thought, well, he doesn't know what he's talking about.
Okay.
And the part was when he was talking about the end of the classical case, when he was talking about a ball spinning, and he says, due to the angular momentum, but it can be all these other places. And it sounded like, well, one just can't tell what angular momentum is with the spinning ball. But I don't think he probably meant that. Maybe he was trying to motivate that quantum mechanics, because it looks at quanta, isn't involving like these continuous possibilities in space. Because it sounded like we just don't know what angular momentum can be. We can't calculate it. It could be straight. It could be like this.
Yeah. So it is from the point of view as a mathematical space. Angular momentum is a vector in R3 space. That's it. And so he's identifying the physical property of angular momentum with what mathematically is a vector space. And now, in the quantum case, it is not anymore R3, and is discrete and has different realm of possibilities. So here he never refers to how angular momentum is a mass R squared, because he's interested in what kind of space that is describing. And here in this side, there are other, we say that each angular momentum is not a vector, like isolated vector in quantum mechanics, but it's a space of vectors. And so he's here talking about vector spaces, and he introduces a notation that is called the bracket notation that is very common in physics. It was invented by Paul Dirac. And it has this bracket in which there is an operator that acts on a state. It produces different states. And he says these two are equivalent. You can either talk about vector spaces or the bracket notation. However,
it's helpful to have that at the back of your mind. I find it useful to think that way, to not get too abstract. On the other hand, I hate matrix-based calculations like this. I think it's just ugly, and having a kind of conceptual idea of what you're doing is much more useful for that.
I think we are losing the video.
It's helpful to have that at the back of your mind. I find it useful to think that way, to not get too abstract. On the other hand, I hate matrix-based calculations like this. I think it's just ugly, and having a kind of conceptual idea of what you're doing is much more useful for that.
So this is the vector space notation, and this is the bracket notation. And he says, I understand it's useful, but I hate it. And that's, he says for a mathematician, this gives you an idea of what you are doing, not like with this one. Well, and typically this notation is very much oriented towards calculation, like calculating what the angular momentum in certain circumstance is, and having a experimental prediction so that you can measure and test things. Whereas this is not, it's totally equivalent. There is nothing that would be true in this notation that won't be true in that notation. But it's not oriented towards measurement, so it's not favored among physicists. And so, do you remember that I said about this idea that animism is about bringing things back to life, like endowing things and symbolic expression with felt qualities, like this coming like this, or the quantum case in which, or this is what the ball does in each case. But also animism gives us room to breathe. And so I want to, what this hate that he says, I hate it, what does hate is about? And one way of understanding his hate is that in the vector space notation, he has room to breathe. He can see, he says, conceptually what is going on. And that in the bracket notation is for him lifeless. It is not endowed with physical, with felt qualities. It's not dynamic, and having room to breathe in part is this feeling the possibility of going in different directions, and so it's not only about animating mathematical symbols, but also animating in such a way that they cease to be lifeless, and then we have room to breathe.
But since like
so I will go through the second case now, and so my intention in this one is to illustrate this idea of animism in relation to symbolic expressions. And, so we have
For now, that includes question and answer.
Yeah, so I wonder, do you have some particular comment about this case of the quantum mechanics? Yes.
I actually had a question, because you were saying that like the certain type of notation gave the constructors respectful room to breathe. Do you think that's inherent to like that particular form? Or is it just that for that constructor that depiction of it was better?
For that instructor.
Okay.
I'm sure that Richard Feynman would feel lots of room to breathe with that notation, but not with the vector space notation. And yes.
I was wondering, don't you kind of lose the tetrahedron if you add 1 and 3 first? Is that not something we can do in this situation? Adding 1 and 3 first and then...
Okay. So when you combine spaces, there is, like, for example, if you multiply 3 numbers, say that I multiply 3 times 2 times 5. I can certainly multiply these 2 first and then times 5, or I can multiply these 2 first and then times 3. This is the associative property. And so these 2 cases encompass all the possible cases, because since this is also commutative, the case in which you add these 2 first, it could be equivalent to commuting these 2, and then you obtain what you had before. So combining the commutativity and associativity, 2 cases is enough for everything.
You get a different number as your intermediate. I don't know, I'm not a math.
Well, it is.
So these are not commutative, you're saying?
You know how in arithmetic they say the associative property, this is equal to 3 times 2 times 5. And so if you add the commutative property, this is also equal to 2 times 3 times 5. Because you turn 2 and with angular momentum it's also commutative. So this is redundant because the commutativity assures that this is also equivalent. No? Okay. Okay, let's go to the second case and then we discuss things. So this is a math major student and Chris Rasmussen is interviewing her. And so first we will see the whole episode is like 1 minute, no less, 40 seconds. So let me show you. So this is a video.
First,
So I will show the whole video and then we'll analyze in parts.
the question deals with absolute value. And so in your thinking, in your mind, what's the meaning of absolute value?
I guess it would be a positive quantity. So like the absolute value of -7 is 7 whole sets, you know? So it's not necessarily like negative isn't taken into consideration. It's more of like a distance almost.
Okay.
I don't know if that makes sense.
Yeah, that's helpful.
So that's the question. What does absolute value mean to you? So first there is the question.
The first question deals with absolute value. And so in your thinking, in your mind, what's the meaning of absolute value?
So this was the first question in the interview, and probably she was apprehensive of what is this guy going to ask me. But after listening to his question, so he is like relaxing, and smiling, and so probably there is some level of tension that was released at that, and so that's also, you know, etymologically, animism comes from anima, which also is related to breathing in Latin, and so and soul and spirit. And so there is something interesting, I think, in terms of breathing, because breathing is the one most central experience in which we are part of the world. There is air coming in and we release air, and the air is inside but is outside, and so there is something about her feeling that she has room to breathe, and she will talk about angular absolute value.
I guess it would be a positive quantity.
So one of the aspects that I want to illustrate in this episode is how when we say animating mathematical symbols, in some cases there is no symbol written anywhere. She's talking about the positive quantity, but she's opened this space for a positive quantity, something that she puts in her very personal space in front of her.
So, like,
so that's these transitions. There is always these fractions of seconds in which what is going to be brought to presence is undergoing birth.
The absolute.
So here there is a gesture that will reappear many times, which is, you know that the symbol of absolute value is two vertical bars. And so there is and there is this kind of gesture that in a way brings the symbol of absolute value. So she first opens up the space for a positive quantity, and she also brings that entity in that space.
Value of -7.
So she says the value of -7, and then she doesn't write -7, but she does -7. Like each one of these motions is bringing to presence another symbolic element, -7. So it's within this realm of the vertical lines, but there is -7 twice.
Seven.
So now there is she says 7.
Whole.
So notice how now she is opening her fingers, like they are 7 whole.
Set.
So there is the idea of a set, because this is a different idea of absolute value. You can think of absolute value as a -7, but or being on a number line, but it's also the idea of a set. And a set is this. And so she's bringing not only the thought of a set, but she's also bringing how sets, what felt qualities are for sets. So this is a set. There are discrete elements. And there is, as she says, 7 whole sets. In each one of these words, it goes gradually, is preparing this finger distribution of sets.
It's not necessarily
So that's I think another transition.
like negative.
So she's talking about the negative. She would say negativism taken into consideration. But when she puts negative on one side, in this case to the right side, so she refers negative is put there. So negative is on one side of her. And she said that isn't.
It doesn't take.
So, so she, let's follow the story of the gesture. So she says, negative isn't taken into consideration, like or the positive is what is. So she's putting on the opposite side. So she's saying this is, and she sort of pushes the negative sideways. Like isn't taken into consideration. So there is this act of not just that's what I understand by bringing things back to life. That is not just a negative and positive that are like dead letters. It is that there is a negative and that is not taken, so I push it away and then this is taken into consideration.
Taken into consideration, and it's more
So here she starts with is trusting into a different. Once the negative is not taken into consideration, so she said it's more like.
Or like a.
So she's searching for that word, but it's almost like, and she would say, distance. Like that.
A distance almost.
Distance almost.
Negative. It's more like a distance almost.
So I'm thinking of that. To me, it feels important to consider this case because, as opposed to other cases, there is nothing written, and yet there are symbolic expressions there, and she's putting them in motion, and she's both animating them and being animated by them, like this thing about sets, or it's almost like a distance, and so these are the two examples. As I said, in this issue of how we develop a monism, as opposed to dualism, a mind-body monism, that the notion of animation and animism can be very important and helpful, because animation is not something that happens in some mental realm that gets expressed there. Is a whole unitary process in which you animate the symbols animate you, and that's part of bringing them to life and having them to breathe. So that's the talk. So we have like 10 minutes, maybe. Yeah.
So this may be off the wall, and just say so if not. But you're familiar with Werner and Kaplan's treatment of symbol formation, right?
Yes.
So you may recall they argue for a primordial sharing situation. There's a differentiation of symbol and referent and addresser and addressee. So I was wondering sort of how you see, I mean, in my mind, what you're talking about very much has this idea of animation as both situated between symbol and referent, where the symbols are motivated in some sense by some animate, some action kind of branch, some embodiment.
Yeah.
And I'm wondering how you see, say, if the interviewer was someone else than Chris Matt Rasmussen interviewing the absolute value individual, how the expressions that went on, how the talk that went on might look very different. And the role of then animation of this symbol reference. Anyway, just your reflections on any of that.
Well, first let me tell that I think Werner and Kaplan, that book is a big source of inspiration.
Yeah.
And they talk about how shapes, we understand simple shapes in a dynamic and expressive fashion, and how, like a sinusoid is like going back and forth maybe, or something that goes like this is cyclical, but it's different from a sinusoid. And so the piece that, Werner was, at least to a large extent, a developmental psychologist. And a lot of problems with the old developmental psychology, I think now it is different, is that this evolutionary sense that children or babies start by being very physical, very bodily, and then as they grow and we develop abilities and become rational and mental. Piaget is a classical case. And so I think that in my reading of Werner, sometimes he falls into that too. And because he has this developmental notion, and he unifies this dynamic interpretation of shapes with children, people who are not educated or primitives, and usually at the time it wasn't uncommon to put together the primitive, the children, and the mentally ill, like people who are in developmental in early stages. So I think it's very inspiring, and I think something also that Werner talks about is how unpredictable things, this interpretation, these perceptual movements happen on the spot. There is no script that you apply, and depending on the context, what emerges can be completely different. Like if Chris wouldn't be doing the interview and someone else would be. So in general, I read and reread a lot of Werner and Kaplan. My only issue is when it comes with this evolutionary.
So I guess just the point that I was seeing if you were going to go in this direction. Dynamic schematizing activity was something that was at the core of the notion of generating symbolic vehicle, generating referential object, and generating link between the two all occurred in an act of symbol formation. And it just struck me that the dynamic schematization in Werner and Kaplan was your animation.
Yes.
Sort of the
I tend not to use a schema thing because I think for example, in saying like these 7 whole sets, you can say, well, this is a schema of sets. And then you can say it's almost like a distance almost. You call that the distance schema. I mean,
well, but then it was an activity.
Yes. But then usually what the word schema brings in is sort of an abstraction that a mental abstraction that we project in what the person does, and without revising whether there is such a thing. Maybe there is no schema. Yes. Yes.
This is a very small thing, but is the last gesture she makes with the distance, is it the same as the one she uses for the absolute value?
Can you repeat it?
So in the video,
Yeah.
she goes like this, right? And that's her absolute value symbol. Is it the same as the one she does to say distance?
Yes.
And is there like anything significant in that?
Yes. Well, it is. This notation of absolute value being two like this, and the two vertical bars,
Yeah.
it reappears. So there is, because almost saying the word absolute value is this. So it's almost like a distance. And so this is an example of what I call fusion, in which the signifier, because this is a signifier. I mean, there is nothing intrinsic about 2 bars that says this is the absolute value. It's a social convention. And there is a signifier, which is what we mean by it. And so she's the signifier and the signified in this emerging dynamic interpretation. Both of them come into place. There is no basic distinction. And so it's like a distance, but it's also like that. And so this merging of signifier and signified, I think is a very important aspect of how we animate mathematical symbols. And even if you have like the ball like this, and you have the dash, line, and the vector that comes like that, it is impossible to distinguish this is a signified or the signifier. It's a spontaneous mixture.
Can you please unpack what you mean by animism gives us room to breathe?
Okay.
Because in the first specifically in the first example that we watched, you pointed out the moment where it says that this is more conceptual, and actually there are arguments to claim that the abstract representation is more conceptual. So, what does really more room to breathe mean in your?
So there is. There is the idea that, for example, we are sentient beings, no, because we sense things. But there is an idea that is popular among the small community that is trying to revisit what animism is, or rethinking. That is the idea that we couldn't be sentient if the things wouldn't be sentient as well. So that, for example, if I see a tree, the tree sees me, and it's through me that the tree sees the world around. And this is Merleau-Ponty developed this notion that if we see something, we are being seen. And that there is this reciprocity. And so breathing is, in our, as living beings, is the major signal of being alive. And the first thing, if someone is dead, either the motion of the pulse or whether it is breathing. And so the idea is that you cannot be alive, or you don't feel alive in a context in which you are surrounded by dead things. And so having room to breathe is this bringing that you feel that things around you are alive. And so if in the case of the student, when she was asked what absolute value means, and she had this deep breathing, is that she came into a context, or felt at that time, that she would explore a realm in which she could be alive, as well as the things that she's representing could be alive. Or in the case of the mathematician, with the bracket notation, he feels he cannot breathe with it. And that has the connotation of being alive. And so I think that a lot of the math phobia and then these negative feelings towards mathematics that are so common in our society have to do with the feeling that confronted with mathematical questions or symbols, there is no room to breathe.
Yes. We're almost out of time, but and this is not a very well-formed question, so I'm sorry. But when she's prompted to make that animating description of absolute value, she's simply asked, "What does this mean to you?"
Yeah.
Is there something about that question that evokes an animating response? And is that just in mathematicians, or is that in everybody?
Well, it evokes, but she feels that she can bring that absolute value to life. And so someone else might not feel that. Mm-hmm. And so every question in a way is an invitation to animate ideas and then symbolic expression, but not everyone can animate those, and it has to do with your life trajectory and how you came to be who you are. Yeah.
Just a comment, maybe a question there, I'm not sure. I totally remember that as a student from day one, I used to hear this term in Hebrew, hand waving, and it's something that has bad negative sentiment, so not really doing mathematics, so just hand waving.
So it's kind of, you're doing something informal, intuitive, but you just handle it. It's not really doing activity. Well, listening to you, I was trying to maybe inspire me to look at hand waving as something that actually represents or even is ways of understanding and thinking. I didn't see that.
Yes, I fully recognize that expression. And there is something sort of negative about hand waving because it means that you don't fully understand anything, you're just making things up. But basically, it's again expressing the dichotomy mind and body. In the way that you are doing things with your body, you are not thinking what this is about. And so if we move towards a monist understanding of mind and body, then this hand waving is imagining and thinking itself.
Yes.
Okay.
Out of time, so thank you so much for coming.